Let's take a look now at section 2.5 and talk about applications of linear equations. One of the primary uses of math is to model the real world, and that's to get an understanding of things in the world. We can use math outside of a math class to make sense of things that are going on in other contexts. We can use math in chemistry, in biology, in physics, in economics, in psychology and sociology in the form of statistics. We can use math to make sense of a lot of different kinds of applications. One way of doing that is by creating what's called a model. Reality is a very difficult thing to understand and a very difficult thing to manipulate. However, if we can get a representation of some situation using math, using equations, we can manipulate those equations more simply on paper rather than to have to go through and manipulate things in the real world. We can use those models, you can use those equations to create predictions of what things can or should happen in various circumstances. And then once we have appropriate models and appropriate predictions, then we can test those. That's one of the basic foundations of many of our sciences. So in this course, we don't go too far into the creation of models. That's something that you see more in a statistics class. However, here, let's take a look at least at one of the basic forms of a model because it fits in directly to what we've been talking about, and those are linear equations. So here, let's talk about an application of a linear equation for making a model. In order to do that, we're going to need a different form of the linear equation. We've already seen the standard form of a linear equation, ax plus by equals to c. And we've seen the slope-intercept form, y equals mx plus b. Here we're going to look at one that is related to the slope-intercept form, but just a little different. This one's called the point-slope form. And it looks like this. Y minus y1 is equal to m times x minus x1. Notice this looks similar to y equals mx plus b, but we have some minor differences, namely this value here, and here this would distribute out this way. Yeah, this is in parentheses. This is called the point-slope form. All right. The point-slope form is this, where x and y are variables, x1 comma y1 is a point on the line, and m is the slope. So here, what we have is something similar to the slope-intercept form, except that with the slope-intercept form, you need the slope and the y-intercept. Here, you still need the slope, but you no longer need the y-intercept. As long as you have any point on your graph, that'll be sufficient to create this kind of equation. This form of the equation, the point-slope form, is useful for creating a model. Meaning, if you have just one little piece of information, one point on your graph, and the slope of that line, the slope of that graph, you can create an equation. So here, this is not different. This is not a different kind of graph. It's still a linear equation. It's still a linear graph. But when put in this form, it's going to be more convenient to create a model. So let's take a look at some examples of how we do that. Note that this is a class in algebra, not a class in statistics or physics or economics. And so our models are going to be a little bit divorced from reality, meaning we're not going to be doing a lot of heavy word problems or anything like that you would see in these application courses. Here, this is an introduction on how to do these things. So let's consider an example. Let's find the equation of the line that passes through the point, let's say the point 3 comma negative 4 with a slope of, let's say, 5. right? Just like that. Incidentally, 5 is like saying 5 over 1. So if you were going to graph this, sometimes people get a little bit mixed up and they say, well, if this is not a fraction, how do I know up and down versus left and right? You can always write 5 as 5 over 1. Now, we're not doing that for this problem, but just keep that in mind. Okay? Here, we're not going to graph, so it doesn't matter if this is written as 5 or 5 over 1. All right, so here, we're going to be using the point-slope form. The point-slope form is used whenever you have a slope, a point, it doesn't matter what the point is as long as it's a point, a slope and a point, and you're trying to create an equation. That's how you know when you're using this form. So here we're going to say y minus y1 equals m times x minus x1. So here we're going to fill in the blanks. y1 is the y value of our point, which is -4. x1 is the x value of our point. So here that's going to be this 3. And then m is our slope. That's going to be the number 5. All right? So y minus y1 equals m times x minus x1. All right? Here, double negative makes that a positive. So we get y plus 4 equals 5 times x minus 3. And that is the point-slope form of this equation. Now, that being said, the point-slope form is useful for creating a model. It's not really useful for anything else. If we're going to be using this equation to now form a graph, we'd rather have it in slope-intercept form. If we're going to use this equation to work with other equations in a system, as we'll see in later sections, we want it in standard form. The point-slope form isn't really useful when it's written this way. It's useful for getting an equation, but once we have an equation, we rarely ever want to leave it this way. So here, let me be a little more specific. We're going to find the equation of the line in slope-intercept form. It is very, very rare, if ever, that we want an equation left this way. So pay attention to the directions of your problems. Usually they'll tell you, okay, find the equation of the line, and they'll tell you how they want it. And most of the time it'll be slope-intercept form. All right, so here, remember slope-intercept form is y equals mx plus b. Okay, so then here I'm going to want to move this over this way. But if I'm going to move that this way, I'm going to have to be able to add it to these numbers over here, which means I first need to simplify this stuff before I can add. Okay, so let me start by simplifying this. Let me distribute my 5. So this will give me y plus 4 equals 5 times x minus 5 times 3. And then I can subtract my 4 and get my result. So here, my equation in slope-intercept form is given by y equals 5x minus 19. And that is the equation of the line that passes through this point through that slope. Okay. Go ahead and give that a try. Find the equation. And again, we're going to go ahead and put it in slope-intercept form. Find the equation of the line in slope-intercept form. That passes through the point, let's say 2 comma negative 3, with a slope of m equals negative 6. All right. Go ahead and pause the video, give that a try, and once you have your equation, again in slope-intercept form, go ahead and unpause the video and we'll do it together. All right, so we want y minus y1 equals m times x minus x1. And we're going to fill in some blanks. y1 is the y value of our point. It's going to be a negative 3. M, well, that's that negative 6 there, times x minus x1. And x is that number there. It's going to be a 2. Okay. So now we can simplify here. Double negative makes that a positive. So y plus 3 equals negative 6 times x minus 2. And that is the equation, but that's in point-slope form. To put it in slope-intercept form, I'm going to go ahead and distribute here. So this will give us y plus 3 equals negative 6 times x, and then negative 6 times negative 2, that's a positive 12. Finally, to isolate our y, let's go ahead and subtract 3 over this way. And that'll give me y equals negative 6x, and then 12 minus 3 will give me a positive 9. And there we go. This is a model, this equation in slope-intercept form. Sometimes you're not given the information directly, but you can put it together using what we've seen in previous sections. An example of that is find the equation in slope-intercept form of the line passing through the points negative 2, 3 and, let's say 5, negative 1. All right. So now here, you're not given the information you usually are. Usually you're given a slope and the y-intercept, in which case you can put it in slope-intercept form. Or you're given a slope and another point, which means you can use the point-slope form, and then modify. But here, you're just given 2 points. In an application setting, in a physics class, or in an economics class, or a psychology class, these would be measurements. Oh, you measured 2 variables and found, whenever x is equal to this, y is equal to that, right? Whenever you add this many grams of a material of a substance, you're going to need to remove this many grams of this other material, or something like that. These are going to be measurements. And once you have those measurements, you can create a model. You can create an equation that describes those measurements. But again, this is not an applications course. This is an algebra course. So here, we're not going to worry about where these measurements came from. These are just some measurements that we got somewhere. All right? Here, what we're going to worry about is making the model, making the equation. All right, so we know we need a slope and a point. Well, we have a couple of points, so we don't need that. We don't need any more points. But we need a slope. Well, yeah, but if these both are points on our line, the slope is just going to be the slope from one point to another. So we can find that ourselves. Here, the slope, m, is going to be y2 minus y1 over x2 minus x1. That was the definition of how, that was our slope formula. Right? That's the formula that tells us how to find the slope. Okay, so that means I got to pick one of these to be point number 1. I'll use that one as number 1. And I got to pick another one to be point number 2. I'll use this point as point number 2. And I'll just plug in my numbers. So it's going to be y2 minus y1 over x2 minus x1. y2, that's going to be negative 1. Minus y1 is going to be the number 3. x2, that's the number 5. And x1, that's the negative 2. Our numerator, negative 1 minus 3 is negative 4. 5 minus a minus, well, that means plus. So 5 plus 2 is going to be 7. So we have our slope. Okay, so now the question comes down to find the equation of the line that has this slope and these points. Okay, so now we know how to do that. Y minus y1 equals m times x minus x1. We can plug in all those numbers. Here, y1, well, again, we said this is the point number 1, so y1 is the y value from that point. So here I'm going to have y minus y1 equals m times x minus x1. Okay, so y1, that's the y value from point number 1, that's the number 3. x1, that's the x value from point number 1, so that's a negative 2. And then our slope is that number we just found. Just like that. And now we can simplify. Let's see here. The double negative will be a plus there. So that's going to be y minus 3 equals negative 4 over 7 times x plus 2. All right, double negative makes that a plus. Now, we need to distribute this across a parentheses. So this will be y minus 3 equals negative 4 over 7 times x, and then negative 4 over 7 times 2, that's going to be negative 8 over 7. All right, multiply those numbers together, gives us this. And now we can go ahead and add 3 to both sides. Add 3 there and add 3 there. And that's going to give us y equals negative 4 over 7x. We can add those together. Remember, if you're adding, you're going to find a common denominator. So that's going to be 21 over 7 minus 8 over 7. It's going to give us 13 over 7. And there we go. So now we have our equation that is in slope-intercept form. Right? Y equals mx plus b. And so that's what we wanted. And there we go. So as you see, this equation is just like the previous equations. But the difference is here you were given information directly. You were told here's a point, here's a slope. Whereas here you're given the same information but somewhat indirectly. There are other ways that the information can be given to you somewhat indirectly. We're going to see one more. Definition. Two lines are parallel if they have the same slope. That's what it means to be parallel. Two lines have the same slope. Two lines are perpendicular, and that's our word. Two lines are perpendicular if their slopes have a product of -1. If you take the slope of one line and you take the slope of another line and they're the same, then the two lines are parallel. If you take the slope of one line and multiply times the slope of the other line and you get -1, then those lines are perpendicular. So for example, y equals 2/3 x plus 7 and y equals 2/3 x minus 1/2. These are different lines, different equations, and they'll have different graphs and different solutions. But since their two equations have the same slope, then that means that the two lines are parallel. Visually, the way that looks is the two graphs are going to run side by side forever. They're never going to get any closer together. They're never going to get any further apart. They're always going to be an equal distance away from each other. For perpendicular, y equals, let's say, 3 over 5x plus 9, and y equals negative 5 over 3x plus 1. Here, these are not the same slope, so they're not parallel. But notice that if I were to take these two numbers and multiply them together, notice that 3 over 5 times negative 5 over 3, 3 over negative 5 is negative 15. 5 times 3 is positive 15. And negative 15 over 15, that's negative 1. So here, their slopes have a product of -1. So the lines are perpendicular. Visually, the way that looks is the two lines will cross each other at one spot, and where they cross, they're going to form a right angle. They're going to form a 90-degree angle. In this class, we don't talk about angles very much, but this is one time we do. They're going to cross at a right angle, at a 90-degree angle. So you can be asked for a line that is parallel to another line, or that's perpendicular to another line. This is still talking about slope, and it's still giving you information about a slope. But just like this equation, just like this problem, it's giving you that information indirectly. And you can still make an equation, just you're going to need to think a little more about the information that was given. So let's take an example of that. Let's have our question be, find the equation of the line. And again, we're going to want to put this in slope-intercept form. That is parallel to the line 2x minus 5y equals to 20, and that passes through the point 1, 6. Okay, so now here you're given a point, but you're not given a slope. Well, you are, just not directly, because you're told that your equation, the one you want to make, is parallel to this equation. But remember, parallel means that this equation and the equation that you want are going to have the same slope. So if you can find the slope of this equation, that'll also tell you the slope of your equation. Once you have that slope, you can use that point and get your answer. So here, let's find the slope of this line. We can do that two ways. One is we can find some solutions and then use the slope equation, use the slope formula, y2 minus y1 over x2 minus x1, but it's probably going to be simpler if we just write this in slope-intercept form. So 2x minus 5y equals to 20. Okay, so now I can solve for y. Let me subtract my 2x over the other way. That goes away. And I get minus 5y equals negative 2x plus 20. And now I can divide everything by a negative 5 all the way across. And this will give me a positive y. Double negative makes that a positive as well. So that's positive 2 over 5x. And then 20 divided by 5, well, that's a negative 4. Okay. Notice this is not the equation that we want. This is a different equation. However, the equation that we're given is going to have, because it's parallel, it's going to have the same slope as the line that we want. So here, this was the given line. But because the given line has a slope of 2/5, that means that the line we want, so our line, will also have a slope of 2/5. Because they're parallel, their slopes must be the same. So now we have the slope of our line. But we also have a point, 1, 6. And so, if we have a slope and a point, now we can make our equation. Y minus y1 equals m times x minus x1. Our y1 is the number 6, our x1 is the number 1, and our slope is 2/5. Just like that. And now we can go ahead and write it in slope-intercept form to get our result. Let's go ahead and start by distributing the 2/5 this way. This gives us y minus 6 equals 2/5 times x minus 2/5 times 1. And now, once we finish distributing, we can finally add the 6 over to the other side, and that'll get us our result. We've isolated our y, and we get y equals 2/5 x. Here, we're going to add these. They're going to need a common denominator. So here, 6 is the same as saying 30 over 5. And if I have 30 over 5 minus 2 over 5, that's going to leave me 28 over 5. And there we go. This is the equation of the line. that is parallel to this line. Notice they're parallel because they have the same slope. And not only is it parallel to this line, but it passes through 1, 6. And there we go. Okay, go ahead and give this a try. We see parallel means they have the same slope. We see that perpendicular means that their slopes, they're not the same, but their product of the slopes is -1. The way that two fractions can multiply to give you -1 is if one is positive and one is negative. So here, these two should have the opposite sign, and they should be reciprocals of each other. If this has got a 3 on top, 5 on the bottom, this should have a 5 on top and a 3 on the bottom. So whenever two lines are parallel, the slopes are exactly the same. When two lines are perpendicular, the slopes have a product of -1. That means one should be positive, the other should be negative, and the numbers should be reciprocated. One on top and one on the bottom. Over here should be the opposite. So give that a try. Find the equation of the line. And again, we want this in slope-intercept form. That is perpendicular, not parallel this time, perpendicular to the line 3x plus 4y equals to 8 and passes through the point 2, 3. Yeah, that's fine. Go ahead and give that a try. Pause the video. Go ahead and use this information to find the appropriate slope. Create your equation, and then make sure that by the time you're done, it should end up in slope-intercept form. Y equals mx plus b. Once you're done with that, and once you have the correct equation, go ahead and unpause the video, and we'll check it together. All right, so let's take a look. Here we have an equation of 3x plus 4y equals to 8. All right, we want to figure out the slope of this line. And we can do that by putting it in slope-intercept form. So let's subtract our 3x from both sides. That makes that go away. And that'll give me 4y equals minus 3x. And then that's a positive 8, so plus 8. And then let's divide everything by 4. And that'll get y by itself is equal to negative 3 over 4x. And then here, if you divide those out, that's just the number 2. All right, so that means that the line we were given is going to have slope negative 3 over 4. All right, so then that means our line, well, it's not going to be the same, because if they were the same, they would be parallel. Here we want a line that's perpendicular. Okay, if they're perpendicular, they're going to need to have opposite signs. Okay, so our given line was a negative, which means the line that we want is going to be a positive. It's going to have a positive slope. And these numbers should be reciprocated. So instead of having a negative, we have a positive. And instead of 3 over 4, we're going to have 4 over 3. So that's going to be the slope of the line we want. Don't use that one. We use this one. Okay, so now we have everything we need. Notice this is the same as the first problem that we got in this section. The only difference is, in the other one, we were told directly, hey, here's your slope. Now we have to play around a little with some information to find our own slope. But it still works the same way. Once I have a slope, and once I have a point, I can create my equation. That equation is going to be y minus y1 is equal to m times x minus x1, where y1, that's going to be the number 3, and x1, that's going to be the number 2, and we know our slope now is 4 over 3. Okay. Finally, let's simplify this to put it into slope-intercept form. Let's go ahead and distribute this number. That'll give us y minus 3 is equal to 4/3 times x. And then if we multiply 4/3 times -2, a positive times a negative is a negative. 4/3 times 2 is going to give us 8/3. Just like that. And finally, we want that y by itself, so let's add 3 to both sides. That goes away. And we get y equals to 4/3 x. Here, these are going to need a common denominator. 3 is the same as saying 9/3. So 9/3 minus 8/3 is going to be a positive 1/3. And there we go. So here, this is the equation of a line. Notice this line has a slope of 4/3. This line had a slope of -3/4. And if you multiply those together, you do get -12/12. Or in other words, you get -1. So yeah, these are perpendicular to each other. And since we use that point, it's going to go through that point. So this is our result. And that brings us to the end of our section. If you note in the section of our textbook, we actually have a little bit more material. We're not going to worry about that. As I said, this is a class in algebra. The last little bit of material in the section of the textbook involves linear regression models. That's something that's best left for either a business math class, a business class, or a statistics class. That's not something we're going to worry about here. So as far as we're concerned, that is it for the material of this section. If you have any questions, comments, or problems, please make a note of that. You can email me or you can ask me next time we meet. I hope everyone has a nice day.